Hey Geometry, I've got a new video for you. It's over section 6.6. And it's all about isosceles triangles and equilateral triangles and how we can use some really basic principles to solve a lot of different types of problems. So the last video, 6.5, set us up to really have a lot of success with just being able to solve for different variable parts in triangles that are just not given to us. But now we're going to talk about some things that the isosceles triangles will unfold. So I'm going to stop yapping about that and get to the content. So we've got a few theorems here that don't really need to be fleshed out too much. They're pretty much just saying, if you've got an isosceles triangle, by definition one in which two of the sides are congruent, that means the angles that live across from those sides that are both congruent, so angle B and angle A, are also congruent. It's as simple as that. If you've got a triangle that shows two congruent sides, then their opposite angles are also congruent. Now, stay with me here. Opposite angles are formed by the sides that are not the side that's opposite to it. So, opposite BC is A. Opposite AC would be B. And then the reverse of that theorem is true too. If you're given that two, and these are called base angles, angles that the base angles are always opposite of the congruent sides, okay? If these two are the same, then you must have opposite sides that are also congruent. So very basic, very intuitive, like you would think that this is true just by looking at a triangle, right? This last one, I don't know if it's intuitive, but it states that if you are given, okay, you know you've got an isosceles triangle, okay? Which means that these sides are congruent and these sides are congruent. What this theorem states is that if you cut a segment there and it creates this angle congruent to that angle, okay, that means two things. One, this sliver right here must be congruent with that sliver right there. And it creates a perpendicular angle. It creates 90 degrees on both sides. That's all that theorem 4.5 is saying. So we're going to use this in order to think our way through several of these problems. So I talked about this in class, but just to save some time, I'm not going to go through numbers 3 through 6. I'm just going to skip ahead to number 7 on the homework. Not on the homework, it's still the notes. Number 7 is our first example from the video that I'm going to explain. And you guys, from remotely, you won't be responsible for 3 through 6, okay? All right, so let's really zoom in on these diagrams. So number 7, find the values of x and y. So right away, we're saying that this is an isosceles triangle given to us. Okay? That means that the opposite base angles must be congruent, which means if this is a 50-degree angle here, there's a 50-degree angle right there. Furthermore, x plus 50 must add up to 180 degrees. So 180 minus 100 must equal x. It's that simple. Over here, we've got another isosceles triangle, which means if this is y degrees, then that's y degrees. Which means 180 degrees equals y plus y, which is 2y, plus the 180 degree angle right here. I'm sorry, the 100 degree angle right there. So yeah, you'll still need to have to know how to solve equations, but they're relatively simple. Take away 100. Divide by 2. Got it. What if we tried number 9? So these tick marks mean that these sides are congruent, which instantly from the isosceles triangles theorem states that their opposite angles must also be congruent, which means this is 52 degrees. Furthermore, if you split the triangle right down the middle here and it creates congruent angles, I should probably change this to double so as not to assume that these angles are the same. They're not. This is 90 degrees, and these two segments must be congruent to each other. That was the 4-5 theorem, the very last one I talked about. So right away you can say that y is equal to 4. And because you know that this is 90 degrees, 90 plus 52 plus x equals 180. So if I take 180 minus 90 minus 52, that gives me x. So x must equal 38 degrees. So not too bad so far. Hold on, let me freeze this so I can figure out what the next example would be. Number 10. Wait, is that my example? Sorry guys, let me double check. Yeah, 10. What am I thinking? So if you look at number 10, it says the perimeter is 54. What's the value of x and y? Well, first of all, if this is 60 degrees and this is 60 degrees, then the y measure also must be 60 degrees. Because 60 plus 60 plus 60 is 180. Furthermore, if all the angles are the same, that means all the sides are the same too. Which means if this side is 4x, then this side is 4x, and that side's 4x. And perimeter just means all the sides added up together. So the perimeter, 4x plus 4x plus 4x, all three sides added together, they add up to 54. This is 12x equals 54. Divide by 12. The value of x, it's kind of a weird thing. It ends up being 4.5. But that's okay. You can get non-whole number values for things like perimeter. Awesome. Okay, what else do we got? 22. Okay. This can be kind of tricky. We've got one isosceles triangle here, which means that this 70-degree angle here corresponds to a 70-degree angle over here. Furthermore, if this side and this side are congruent, you've got another isosceles triangle, which means this angle here and this angle down here are also congruent. So this little box indicates it's 90 degrees. If this is 70, the remainder must add up to 90. So 70 plus 20 adds up to 90, which means that's 20 over here. Which means x plus two 20s must add up to 180. Okay? So all you're doing is taking 40 away from 80 and you're getting the value of x. X is 140 degrees. Check out 25. So again, we've got two sets of isosceles triangles in here. One that creates an isosceles right here, which makes this 58 degrees because these two have to be congruent. But then this one over here, it's a right triangle that's also isosceles. So this angle, we don't know what it is, must be congruent to this angle over here. Now, if you have two of the three angles in this triangle, you can solve for x right off the bat. So x is equal to 180 minus the other two measures, minus 58, minus 58. Let's see, this is like 180 minus 100, which is 80. And then take away 16. 80 minus 16, 64. Let's just double check our math on that. I've been making mistakes left and right today, so there's no shame in checking. 64, okay, we were right that time. Awesome. All right, now it's going to be really hard to find the value of y. Except, if I know this is 90 degrees, and I know these have to be the same, I could apply a variable to those unknown parts. So I'm not going to use x, I'm not going to use y, I'll just use z. So let's say that this angle measure right here is angle z, which means this measure is also angle z. If I had 64 here and the z measure here, then the last angle y would have to add up to 180. So the reason why I'm trying to solve for z is because it's eventually going to help me get to y. So z plus z, which is 2z, plus 90, those three angles have to add up to 180. Which means those two angles have to add up to 90. And they are the same. They're both 45 angles. So this is 45 degrees because 90 divided by 2, is 45 degrees. So z is 45, which means that z is 45. And therefore, these three angles added together, they got to add up to 180. So you take away 45, you take away 64, and you've got the value of y. So, you know what? Let's use our handy-dandy calculator. Y equals 71. All right, now we're going to jump ahead to number 34. I'm going to do a couple of these and then we'll end up on a multiple choice problem at the very end. So down here it says find the values of m and n. So here's what we're doing. We're still talking isosceles triangles, right? So these little tick marks mean that this angle here is congruent to this angle. So n is right here. Again, n plus n, so 2n, plus the 126, they make up the three angles of this obtuse triangle they have to add up to 180. So if I solve for n, that's going to get us one step closer to solving for m. So subtract 126 from both sides. You get 54. N equals 27. So we solve for the first one. We now have that this is 27 degrees, and these two have to add up to 180. So take 180 minus 126. And that gives you this degree measure here. 180 minus 126 is 54 degrees. All right, I'm just using the fact that these two angles have to be supplementary. They have to add up to 180 degrees. Now we have 2 out of the 3 angles in a triangle. 54, 90. Take 180 minus 90 minus 54. Which, if you do those calculations, you get 36 degrees is going to be our last angle right here. So m equals 36. Kind of tricky, but not so much so. Check 35. Equilateral triangle thrown at us. We know right away it's a 60-degree measure here, a 60-degree measure here, and a 60-degree measure there. Always, every equilateral triangle has 3 60-degree angles, which means this right angle got split up into 60 degrees plus 30 degrees. So n is equal to 30 degrees right there, because that's the only way you're going to come up with 90 right here. And then if this is 30, then this one has to be 60 in order to keep the triangle sum. 60 plus 30 plus 90 is 180. All right, we're moving along. Again, slightly longer video. My apologies, but, math is sometimes inconvenient, and we must adjust. Oh, this is something special here. Interesting. Okay. So, this was going to be harder to visualize, but here's one isosceles triangle that they're trying to show us, and here's the second one. Now, the second one shows that this little sliver of an angle right here is going to be n. Okay? And these three have to add up to 180, right? So n plus n is 2n plus the 90. Those three have to add up to 180. Sorry. When you solve that equation, you get that the n is 45 degrees. So n, right off the bat, gives me 45 degrees. So 45 here, 45 there. Now this also means that this angle here must be congruent to this angle here. This angle is m plus 45 degrees. So m plus 45 plus m plus 45, right? Because if these are congruent, then this has to be m plus 45, plus the 50-degree angle. So this angle plus this angle plus this angle, m plus 45 twice plus 50, those have to add up to 180. Yeah, this is a little bit more intense. 2 m's, 90 plus 50 is 140, equals 180. Take away the 140 from both sides. 2m is equal to 40. M is equal to 20. And that's that. All right, last one is number 48. Sorry, I'm trying to manage this a little bit. It's proving to be difficult. All right, number 48. So it says an isosceles triangle, the measure of the vertex angle, which, by the way, if I were to draw an isosceles triangle, these would be the base angles, which are congruent. This is the vertex angle. Okay? The measure of the vertex angle is 4x. So this is 4x. The measure of each base angle is 2x plus 10. So this one and this one are both 2x plus 10. What is the measure of the vertex angle? So it seems like here's what we got to do. Add them up, set it equal to 180. That'll help you find x, but we need the vertex angle. Then you plug x in up there in 4x. So let's do this. Can you guys see that? Yep. All three of these angles, bam, 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 they add up to 180 degrees. So 8x plus 20 equals 180. Take away the 20, divide by 8. X equals 20. All right, now they tricked us. Oh boy. They got the answer 20. But that's not the vertex angle. That's the value of x. You now need to take your x equals 20 and plug it into the expression for the vertex angle, 4x. What's 4 times 20? It's 80. All right, guys. Wow, that's a lot of video. Let's end it here. All right, thanks for watching, and good luck on the 6.6 problem set.